Hello students, I am Rashta from Vagdevi College of Engineering, Department of Computer Science and Engineering. In this session, we are going to learn about data structures through C++ lab programs. Week 6 program. Write a C++ program using class templates to implement the stack ADT using an array. In order to implement this program, we have to learn some concepts here, data structures and stack. Data structure. Suppose if I want to search a particular word in a dictionary, it will be easy. Why? Because the words in a dictionary in a sorted order. Suppose if I want to reach a particular destination, using Google Map, I can reach the destination. If I want to store the student records in a rows and columns format, I can use the tabular format. In these three concepts, the data will be stored in three different structures. So what is a data structure? Data structure is most fundamental building block concept in computer science. To build a software system, we use data structure. So what is the definition of data structure? Data structure is a particular way of organizing data in a computer so that it can be used effectively. Data structure is logical or mathematical organization of data. It describes how to store the data and access data from the memory. A data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. Types of data structures. We have two types of data structures, built-in data structure, user-defined data structure. Under built-in data structures, we have integer, float, character, and etc. Under user-defined data structures, we have two types of data structures, linear data structure and non-linear data structure. Under linear data structures, we have array, stack, queue, linked list. Under non-linear data structures, we have trees and graph. Other than these data structures, we have files and hashing concepts. Linear and non-linear data structure. In linear data structure, the data items are arranged in a sequence fashion. Or in linear data structure, the data is organized in a linear order in which the elements are linked one after the other. In nonlinear data structure, the data items are not in sequence. In the nonlinear data structure, the data items are not stored in a sequential manner, rather the elements are hierarchically related. In linear data structures, all data elements are present at a single level. In nonlinear data structure, the data elements are present at multiple levels. In linear data structures are easier to implement, and nonlinear data structures are difficult to understand and implement as compared to linear data structures. In linear data structures can be traversed completely in a single run. Non-linear data structures are not easy to traverse and needs multiple runs to be traversed completely. These are some of the differences between the linear and non-linear data structures. Data structure examples. Online movie ticket booking. The seating arrangement like two-dimensional array that is in the form of rows and columns. Suppose if I want to book a seat numbers D4 and D5, D is the column and 4 and 5 is the row numbers. Web browsing. The searching topics are stored in a stack. Suppose if I want to search a particular word, go to the Google Chrome, search the topic. Under the topic, the number of sites will be displayed. If you want to click a particular site, and that site address will be stored into the stack. So on, you are going to click the number of sites, and all those sites will be stored into the stack. Suppose if I want to reach the starting location, starting site, you have to come across all these sites whatever you are clicking number of times, and this is the example of stack here. Railway ticket booking, it is a first come first serve process, and it is an example for queue data structure. Music player, after completion of one song, automatically the next song will be played. It is an example of linked list, and we can move to previous and next songs also. Google Map. Each and every city is connected with the routes. So it is an example of graph. These are some of the real-time examples. Stack. Stack is an abstract data type. Stack is similar to linear data structure which follows a particular order in which the operations are performed. The order may be first in last out or last in first out. The applications of stacks are, in parsing technique we are using the stack, And to convert the infix to postfix and postfix to prefix, we are using the stack application. And if you are taking the backward and forward stacks on browsers, and undo redo stacks in Excel and Word. Activation records of method calls. Example, recursive function call. Suppose if you are calling the number of times a particular function, and that function will be stored into the stack. So these are some of the examples of or applications of stack here. If you are taking the push operation, it will take the big of one time, and pop operation also big of one time, and top operation one time, and search operation is also big O of n times. So the structure of stack is look like this. So we have only one end top. Using top end, we have to insert the element, means we have to push the elements, and using top end only we have to pop the element from the stack. So Tower of Hanoi is the best example of stack. We have to sort the plates in a order. Stack ADT. Push function adds an item in the stack. If the stack is full, then it is said to be an overflow condition. Pop removes an item from the stack. The items are popped in the reversed order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. Display. This is used to display the values of stack if the stack is not in underflow condition. So the table represents the position of top and stack status. If the top is -1, stack is empty. If top equal to 0, only one element in the stack. If top equal to n-1, stack is full. If top equal to n, overflow condition occur. Stack operations. Initially the stack is empty, then top equal to -1. Suppose if I want to push 10, first we need to increment the top value, that is incremented by 1, and that particular updated position we need to push the value 10. Suppose if I want to push one more element, first we need to update the top value, then we can push the element into the updated position. I need to push one more element, 30, update the top value, push the 30 element. Push 40, update the top value, push 40. Now the stack is full. Now I want to pop the element from the stack. Automatically 40 element will be deleted. Why? Because 40 is the top element, and the functioning of stack is last in first out and first in last out. So if I want to pop the one element, automatically 40 element will be popped from the stack. After popping the element, we need to update the top value, that is we have to decrement the top value by 1. Now it becomes 2. Now I want to pop one more element. Automatically 30 will be deleted. After deleting the 30 element, we need to update the top value by 1. Now I want to delete one more element. 20 will be deleted. Update the top value by 0. Delete one more element. Update the top value. Now top becomes -1. Now the stack is empty. Suppose if you want to pop the element, it is not possible. Why? Because the stack is empty. Stack operations. Push function. So what are the steps involved in the push function? Step 1. Check whether the stack is full. So again we check the condition with the top condition, top value, top equal to size -1. If it is full, then display stack is full, insertion is not possible, and terminate the function. If it is not full, then you can increment the top value by 1, and in the top position you can insert the value. So this is the code for push function. Pop. First step, check whether the stack is empty. So in order to push the value, we need to check the condition full, and in order to pop the value, we need to check the condition empty. So top equal to -1. If it is empty, then display stack is empty and deletion is not possible, and terminate the function. If it is not empty, then delete stack of the top, means top element, and decrement the top value by 1. So this is the code for pop function. Display. In order to display the values of stack also, we need to check the condition empty. So top equal to -1, condition. If it is empty, then display stack is empty and terminate the function. If it is not empty, then define a variable I and initialize with the top and display the stack values and decrement the y value by 1. So repeat this step until I value becomes 0, and this is the code of display. Stack operations. Now initial stack is -1. So I am taking one more example for stack here. Stack is empty now. I want to push the value 10. So first we need to increment the top value from -1 to 0. Now in 0 location we can insert the or push the value 10. Now I want to push one more element 20. So first update the top value, then push the element. Then push 30. Update the top value, then push 30. Then push 40. Update the top value, then push 40. Now the stack is full. Now I want to pop one element. Automatically 40 will be deleted. Why? Because 40 is the top element. Now I want to pop the element. 40 will be popped from the stack. Then after popping the element, we have to update the top value. That is, we need to decrement the top value by 1 when you want to pop the element from the stack. Now top becomes 2. Now I want to pop one more element 30. Delete the 30. Update the top value. Then pop one more element, pop 20 and update the top value. And pop one more element, pop 10 element and update the top value. Now the top becomes -1. Suppose if you want to pop one more element from the stack, it is not possible. Why? Because the stack is empty. So like this we can implement the stack operations. Now let us see the execution part. Now this is the stack program using arrays and templates, and here we are using the two header files, iostream.h and stdlib.h, that is standard library.h header file, and this is the syntax for template using class templates, and this is the class here ending with the semicolon. And next we have a push function, and we need to check the condition for push top equal to n-1. And next pop function top equal to -1, and for display also we need to check the condition top equal to -1. And using for loop we need to display the values of stack here. This is the main function, and using while and switch cases we are going to execute the program push pop display operations here. Now let us try to compile the program. So if you have any errors, it is going to display here. You don't have any errors. Now try to run the program. Now enter the size of stack. Now we need to give the input to the size of the stack. So let us check the size of the stack is 3. Means maximum we can enter the 3 numbers into the stack here. Now so we have a menu here, 1 for push, 2 for pop, 3 for display and 4 for exit. Now the stack is empty. Let us try to pop the element from the stack, that is the 2 choice. So what is the condition here? Stack is underflow. Why? Because we don't have any elements in the stack. Now try to display the values also. Same, stack is underflow. Why? Because stack is empty now. Now try to push the elements using one choice. Enter the element. Take one more element 20, one more element 30. Now till now we pushed the 3 elements into the stack, that is 10, 20, 30 now. Now try to push one more element now. Stack is overflow. Why? Because we are taking the size of the stack is 3 only. Okay. Now try to display the values 3. Now see here, stack of 2 is 30, stack of 1 is 20, stack of 0 is 10. So in a last in first out, first in last out order, it is going to display the values here. So last element, recently we pushed the element, that is 30. Okay. Now try to pop the element. Automatically the top element will be deleted, that is 30 will be deleted now. Now try to display the values. Now the stack consists of only 2 elements, 20 and 30. Yes. Okay. Now let us take the choice, one more choice, push function. I'm going to insert the value 50 now. Now this is the topmost element. Now try to display the values. 50 is the top element. Now case 4, exit. So like this we can execute the stack program using arrays and templates. Thank you.